In today's class, inshallah, we are going to do questions on Cayley-Hamilton theorem. First, we must by heart this sentence. What is Cayley-Hamilton theorem? Every square matrix satisfies its characteristic equation. Every square matrix satisfies its characteristic equation. Let me understand it little. What is the characteristic equation? This is mod of A minus lambda I equals to 0. This is the characteristic equation. Suppose we solve this, suppose we get a cube equation lambda cube minus 3 lambda square plus 2 lambda minus 5. Suppose some equation we get. Now, what is the meaning of Cayley-Hamilton theorem? Means if we keep the value of a in place of lambda, we must get 0. This is the characteristic. Every square matrix satisfy its characteristic equation. This is the characteristic. If the matrix satisfies, then we must get this value 0. A cube minus 3a square plus 2a minus 5 into I must write equals to 0. Watch carefully. When we keep in place of lambda a, we say if we get 0, we say the square matrix satisfy its characteristic equation. How to solve now? We must get the characteristic equation in terms of lambda as a polynomial. Then we must keep in place of lambda a. We must get 0. Then we say that the Cayley-Hamilton theorem is verified. Also, we know this basics. Okay, you remember this A into A inverse equals to A inverse into A equals to I, and another formula is A into I or I into A is A. So let me do one question on this Cayley-Hamilton theorem. Every square matrix satisfy its characteristic equation. That means if we put in place of lambda A, we must get 0. If we put in place of lambda A, we must get 0. If we put in place of lambda A, we must get 0. This is the Cayley-Hamilton theorem. Now let me see one question. Verify Cayley-Hamilton theorem and hence find A inverse using Cayley-Hamilton theorem. Now how to start? First let me suppose the matrix as A. Let A equals to 2, 1, 2, 5, 3, 3, minus 1, 0, minus 2. Now what is the characteristic equation? The characteristic equation is, what's the formula we have? A minus lambda I equals to 0. Now we already discussed about this, how to write the A minus lambda I. With these elements, diagonal elements, you add minus lambda, 2 minus lambda, 3 minus lambda, minus 2 minus lambda. You write the remaining numbers as it is. This will become the characteristic equation. 2 minus lambda, you write 1 as it is, 2 as it is, 5, 3 minus lambda, 3, minus 1, 0, minus 2 minus lambda equals to 0. Now if we expand the determinant, we'll get a polynomial of cubic equation. Now let me solve this one. 2 minus lambda into, if you take this, multiply this 2 minus this 2, 3 minus lambda into minus 2 minus lambda minus 0 into a number is 0. You always change the sign of this. This is plus 1, so you write minus 1. This is plus 1, so you write minus 1. Now this into this minus this into this. So 5 into minus 2 minus lambda minus 1 into 3 minus 3. That will be minus 1 as plus 3. Again watch. You have to change the sign of this. Always change the sign of the middle term. This is plus 1, so write minus 1. You hide this column. 5 into minus 2 minus lambda minus into minus plus 3. Now plus 2 into, now you write this one, 0 into 5, 0, you hide this minus of minus plus 1 into 3 minus lambda equals to 0. Now let me solve this one. See the next continuation. Now 2 minus lambda into, so if you multiply this plus into minus, this will be minus 6 minus 3 lambda minus 6 minus 3 lambda minus into minus plus 2 lambda minus into plus lambda square. So I'm writing first lambda square, then minus 3 lambda plus 2 lambda will be minus lambda, now minus 6. Now next one, now we have to multiply this one. So plus into minus, minus 5 2s are 10, minus 5 lambda plus 3, plus into minus, minus 5 2s are 10, plus into minus, minus 5 lambda plus 3. So this will be, if write first, I'm writing first lambda, minus 5 lambda. Now minus 10 plus 3 will be minus 7. Now last here, plus, you leave this 0, 2 into 1 will be 2, 2 into 3 minus lambda equals to 0. Now let me multiply the here. First you multiply all the terms with 2. 2 into lambda square, 2 lambda square, minus 2 into lambda, 2 lambda, minus 2 6 are 12, minus into plus minus, lambda into lambda square, lambda cube, minus into minus plus lambda into lambda, lambda square, minus into minus plus 6 into lambda, 6 lambda. Now minus into minus plus 5 into lambda, 5 lambda, minus into minus plus 7, plus 2 3 is 6, minus 2 lambda equals to 0. Now first write the lambda cube, minus lambda cube. Now we are having two terms of lambda square. 2 lambda square plus lambda square will be 3 lambda square. Now you see lambdas, how many are there? See here, 5 plus 6 is 11, 11 minus 2 9, 9 minus 2 7, plus 7 lambda, minus 2 7 lambda. Now lastly constants, 7 plus 7 plus 6 13, 13 minus 12 will be 1, plus 1 equals to 0. Now see here, let me take minus common here. If you take minus common, this will become plus lambda cube, minus 3 lambda square, minus 7 lambda, minus 1 equals to 0. Minus, sorry, 1 equals to 0. So this is the equation of the characteristic equation. Now see here, now we apply the Cayley-Hamilton theorem. First let me write what is Cayley-Hamilton theorem. Cayley-Hamilton theorem is every square matrix satisfy its characteristic equation, satisfy its characteristic equation, that means, what does it mean? That means this is the characteristic equation and the square matrix is A. So if we keep A in place of lambda, we must get 0. This is the Cayley-Hamilton theorem. That is, what should we get? In place of lambda, you write A cube minus 3a square minus 7a minus, with constant you must apply I. Suppose we are having here 3, so we must write 3i. If we are having 5, we must write 5i. So we are having 1 into I will be I equals to 0. Now we have to verify this Cayley-Hamilton theorem. We have to find a square, a cube, then we use this, we must get 0, then the Cayley-Hamilton theorem will be verified. Now see here, we have to prove this a cube minus 3a square minus 7i minus I equals to 0. First we have to find a square, then a cube. We know a square equals to a into a into a. Whereas a cube equals to a square into a. Now a into a is this, the matrix a into a. Now I'm taking directly from the calc. You see here, I'm using the calc. Now watch here, first we have to use mode. If you go into mode, you get, I'm showing the calci 991. Okay, you see here on the sixth number you are having matrices, so I am taking 6 matrices. We want matrix A, suppose, so we want the first one, matrix A, and this is 3 by 3, so we take the dimensions 3 by 3. Now let me substitute this one. 2 equals to 1 equals to 2 equals to 5 equals to 3 equals to 3 equals to minus 1 equals to 0 equals to minus 2. So now we see here, we have taken the matrix A. Now we want A square, no? So that is A into A. We can go from here. You see here, shift, we can use shift. And you see shift after shift, in place of 4, we are having matrix. So we have taken matrix. So we want matrix A. So take 3, matrix A, into, again we want matrix A into matrix A. matrix A into matrix A. Again you apply shift and take 4. Again we want matrix A, that is third one. So matrix A into matrix A, matrix A into matrix A. So we got this value. Let I write these values. So we get this one 7, 5, 3 and 22, 14, 13, and last is 0, minus 1, 2. Now again a cube will be a square into a square just got no 5, 7, 5, 3, 22, 14, 13, 0, minus 1, 2. Now already we got a square into a, will get the answer. Okay, again we can write like this, into means answer into a square into a cube. Again we can take a from here third, so a square into a will get a cube. So I'm writing the value of a cube. So we get a cube as 36, 22, 23, 101, 64, 60, minus 7, minus 3, minus 7. If you are getting problem to understand the calci work, you can ask with your professors in the college. Okay, so we got a cube also, a square also. Let me substitute this all in the equation. Okay, now see here I written some steps already. Now you substitute in this value. This is the equation. A cube we got this one, minus 3 into a square you got this one, minus 7 into we got a, the value of a is this, and I is the identity matrix 1 0 0 0 1 0 0 0 1. Now how to solve? See, there are many methods. I am showing like this. You see, you do one thing, write the first elements of all the matrices. Here the first element is 36. This is minus into plus, minus 7 3s are 21, minus 2 7s are 14, minus 1. The first terms we wrote. In the second, in the same way, second elements of the first row, 22, 22, minus into plus, minus 3 5s are 15, the minus 7 1s are 7, minus 0. In the same you write the third terms, 23, minus into plus, minus 9, minus 7 2s are 14, minus 0, minus 0. Now come here for not 1, minus 3 into 22 is 66, minus 7 5s are 35. Okay, and this is minus 0, sorry, minus 0. Now here 64, minus into plus, minus 42, 3 into 14 is 42. Now here minus 7 3s are 21, minus 1, minus 1. Now lastly here 60, minus into plus, minus 39, minus, we are writing the third term. See here 60, here 60, minus 3 into 13 is 39. See here I wrote 0, actually it's 3 here, minus 7 3s are 21. Now last this step, minus 7, 3 into 0 is minus 0, minus 2 is plus 7, minus 0. Here minus 3, minus 2 is plus 3, plus 0, plus 0. Lastly minus 7, minus 6, minus 7 here, actually it's minus 7, minus 6, okay, minus into minus plus 14, minus 1. Now see here the last, I think we get all these zeros you see here, equals to 36 minus 36 will be 0, 22 minus 22 will be 0. Okay, here we did some mistake, I think. 23 minus, yes, minus 2 sevens of 14, it's 14 actually. So 23 minus 23 will be 0, and 101 minus 60, this will be 101 will be 0, 64 minus 64 will be 0, so we'll get 0 all. Okay, you just verify whether we done some mistake, but anyhow we'll get this value 0, 14 minus 14 0. Hence we got, hence therefore what we got, a cube minus 3a square minus 7a minus I equals to 0 matrix. Okay, hence we can write, hence Cayley-Hamilton theorem. Cayley-Hamilton theorem is verified. Hence Cayley-Hamilton theorem is verified. Now we have to go into the next part. We have to find A inverse. Using this we will find A inverse. Now using Cayley-Hamilton theorem, this we have to find A inverse. We can find A inverse directly, but here the question is using this equation we have to find A inverse. So the first step is multiply each term by A inverse. How to find A inverse? Multiply by A inverse. You do one thing, you multiply each term by A inverse. So it will be A inverse into A cube minus 3A inverse into A square minus 7A inverse into A minus A inverse into I. Now I'll explain the terms. See here, we have multiplied every term with A inverse here. Now first term, how can we change what's here? A inverse into A cube. We can write A inverse into A cube. We can write A into A square. A into A square. Why we are writing like this? Because we know A inverse into A will be I. A inverse into, just we have understood this in the starting of the class. I explained A inverse into A will be I. So I into A square. If you multiply with I, you will get the same matrix. This is identity matrix under multiplication. So I into A square is same as 1 into 5 is 5. 1 into 5 is 5. Same as AI into A square is A square. Whenever we multiply with I, we'll get the same matrix. So A inverse into A cube, we got A square minus, here next term, A inverse into A square. We can write like this, A inverse A square, we can write A into A. So A inverse into A will be IA. Now I into A will be A. So minus 3. A inverse into A square get as 3A minus 7. A into A inverse will be I equals to 0 is there here. A inverse into A will be I minus, just now I explained, whenever we multiply it with I, will get the same matrix. A inverse into I is A inverse. A inverse equals to 0. Now the next step is bring A inverse here. So we get, therefore A inverse equals to, I brought this minus inverse here, it will be plus. What's left here? A square minus 3A minus 7I. So A inverse equals to, let me write this values minus 3 into A. A is 212 and 533 minus 10 minus 2 minus 7 into I. I is, the value of I is 100,010,001. Now I just substitute. Now let me substitute what is the value of A square from the previous. Just now we have find the A square. A square is 753, 22, 14, 13, and lastly 0 minus 1, 2. So this is the A square. Just now we have done this. This is A square. Now let me substitute the values. We'll get the answer. So this is equals to 7 minus into plus minus 6 minus into plus minus 7. Watch carefully. 7 minus into plus minus 6 minus 7. Now the second terms, 5 minus 3 ones are 3. This is 0. No need to write 0. Now 3 minus 3 twos are 6. Here it's 0. Okay. Now come here, 22 minus 3 fives are 15. 0 here. Now 14 minus 3 3 is 9. 3 threes are 9 minus 7 ones are 7. Now here 13 minus 3 threes are 9 minus 3 threes are 9. That is 0, leave 0. Now lastly here 0, 0 minus plus 3, again 0. Now minus 1, 0, 0. The last is 2 minus plus 3 to the 6 minus 7. So A inverse will be minus 7 plus 7 will get cancelled. We left with minus 6. We left with minus 6. The next one is here 5 minus 3 is 2, and here is minus 3 and 7. 14 minus 7 is 7. 7 minus 9 minus 2. 13 minus 9 is 4. 3 minus 1. 6 plus 2, 8 minus 7 is 1. So this is the A inverse. Therefore, we got A inverse. Therefore, A inverse equals to minus 6, 2 minus 3, 7 minus 2, 4, and 3 minus 1, 1. So this is the method to find A inverse using Cayley-Hamilton theorem. Now see here the next question. If A equals to this value, Using Cayley-Hamilton theorem, find the value of a power 8 minus 5 a power 7 plus 7 a power 6, whatever. So this is, we have to find the value of this using Cayley-Hamilton theorem. I wrote few steps because to reduce the time of the video. If we write every step, the time will be so lengthy. So I did by our, you know already what is a, that characteristic equation is a mod of a minus lambda equals to 0. So if we take mod of a minus lambda I, we get these equations, okay, and if you multiply this, you'll get the equations. You do this by yourself. Already we have done many questions on eigenvalues also. So after multiplying, we get the cubic equation. This is the cubic equation we got in polynomial lambda. So according to Cayley-Hamilton theorem, in place of lambda we keep a, in place of lambda we keep a. So this is Cayley-Hamilton theorem, a cube minus 5a square plus 7a minus 3i. Now using this, actually using this, we have to find the value, okay. So you remember this, we have to use this to prove the given formula, okay. Now let me continue using this one, okay. Now see here, we already written this, we proved this, a cube minus 5a square plus 7a minus 3i equals to 0. According to Cayley-Hamilton theorem, this is 0. A cube minus 5a square plus 7a minus 3i is 0 according to Cayley-Hamilton theorem. Now using this, we have to prove this one. You do one thing, from here to here, you see here, we can take common. What we can take common? Let me take common a power 5. If we take a power 5 common here, what is left here? It is left with a cube minus 5 into, what is left here? If you take a 5 a power 5, it is left with a square minus plus 7 a power 5, we have taken a, and minus 3, we can write 3i. 3 is left, but write 3i, okay. Now again here we can take common from this, okay. Up to here we can take common a. So if we take common a here, what is left here? A cube minus 5a square plus 8a minus 2. You write 2 as 2i plus I. Now see here, this value is 0 according to Cayley-Hamilton theorem. So a power 5 into 0. I'm writing as it is. In the next step I will change this one. So a into a cube minus 5a square plus 8a minus 2i bracket I. So this becomes 0. Now watch carefully, there is slight change between this. You see here, we can change like this. Watch carefully. Equals to a into a cube, you write as it is a cube minus 5a square. We want 7a, so you can write 8a as 7a plus a. 7a plus a. Why we are changing like this? Because if we get this one, this value will be 0. So a cube we already having, we don't change. Minus 5a square as it is, we don't change. 8a we can write 7a plus a, okay. Then minus 3i we are having here minus 2i. So we can write minus 3i plus I. See here, minus 3i plus I will be minus 2i. Again we left with I here. See, watch carefully. We have to change this into this a cube. There is no change. Minus 5a square. We want 7a. So write 8a as 7a plus a. 8a as 7a plus a. Now minus 3i we want. We are having minus 2i here. So minus 2i can be written as minus 3i plus I. Minus 2i can be written as minus 3i plus I. Why you are adding? Now we again have this value 0. So what is left here? A into this is 0 plus a plus I bracket plus I. Sorry. So what is left here? Multiply a into a square plus a into a plus I. That means we have to find a square plus a plus I. Now let me substitute the values. We already have find the values of a square, a and I. I is 1 0 0 0 1 0 0 0 1. The value of a is 2 1 1 0 1 0 1 1 2. Now let me find a square. You can find the a square from calci and you substitute the value. I'll substitute just now. Now see here, I wrote the value of a square from calci. A square from calci. Now let me just add the first terms. 5 plus 2 is 7 plus 1 8. 4 plus 1 5 plus 0 5. 4 plus 1 5 plus 0 5. 0 0 0 0 0 remains 0. 1 plus 1 2, 2 plus 1 3, 0 plus 0 plus 0 it remains 0, 4 plus 1 5, 4 plus 1 5, 5 plus 2 7 plus 1 8. So we got this value. So you practice these types of questions, especially verify Cayley-Hamilton theorem and hence find A inverse. It's a very important question. Okay, we did one question in detail. I request to practice like this one or two questions more, so you will get the perfection in this. Okay, so inshallah we are going to continue in the next class. I request you all to subscribe my channel and share and like my channel. Inshallah I will continue in the next class.